Samba on Z series machines, mainframes. And it's one of the penances for working for IBM. You have to deal with mainframes occasionally. And it wasn't scaling very well. It wasn't very fast for large numbers of users. And we discovered that something unexpected. When Samba starts up, if say 1,000 users connect, each one gets their own process. Each of those processes takes a single byte read lock on each of the databases in Samba just to mark the database as it's being used. Don't remove this database, it's being used. And each separate process does that. So each separate process asks for this read lock just to make sure that, just to mark the file as in use. And what we didn't understand is this. Now, let's see it was called lock scaling. Okay, so I wrote a test program because I found that the locking wasn't scaling very well. I'll show you what lock scaling does. This is a bit of junk code that I wrote to try and diagnose this problem. And this is currently the locking subsystem in the Linux kernel is being rewritten as a result of this. But it also affects lots of other Unixes. What this program does is it establishes, say, 1 or 10 or 100 locks on a file, then it measures the speed of adding one more lock. So it sets 100 locks, and then one other lock here, and it says sets it, unsets it, sets it, unsets it. It says how fast is it to do that one extra lock? Because that's what Samba did. All these idle... see, most users, this machine was being used in the public service, and most public servants are idle. Yes? So these thousands of public servants were sitting there doing nothing, but they had a 1 byte lock on this file, and that 1 byte lock was there just to say, I'm here, don't delete this file, I'm here. And then there was one active user, the person with the deadline the next day. Yes? And that one active user was copying files. And we discovered that that one active user, the performance was very poor, not nearly as good as it should have been. And this is why. Let's run this test program, and let's run it with, say, no extra locks. So what this will do, this is measuring the speed of locking, and on my laptop I'm getting over 100,000 locks per second with no extra locks. Let's now, say, have 100 public servants sitting there. Yes? Now with 100 public servants, we're now locking at 64,000 locks per second. Yeah? So those 100 locks that are just sitting there idle, not doing anything, then this extra lock is now almost half the speed. Let's now have 2,000 public servants sitting there. We're down to 8,000 locks per second on that extra lock. So those 2,000 idle locks not doing anything have lowered the speed of that one active user by a factor of 12. But then my maths right, that's about 12? Close enough. Close enough for government work. So it's much slower. Now on the Z series machines I was using, it was a bigger factor. It was a factor of about 30 or 40. Much slower, very noticeable. So we're doing two things to fix this. First of all, we have modified Samba for the next release coming out in the next week or two to not set these idle locks. We use a different technique for marking the file as being in use. And the second thing we're doing is we've convinced somebody to rewrite the locking subsystem in the Linux kernel to use a tree, what's called an interval tree, because the kernel was using a linear linked list. So there were 2,000 locks in this linked list, so setting one more lock meant it had to walk this 2,000 long list, get to the bottom, add one more lock. Yes? In fact, it walked it twice, because it walked it once to find if there was a conflicting lock, then it walked it again to add the lock, twice for every traverse. So you might think, wow, isn't this Linux thing terrible? So I tried this on Solaris, IRIX, AIX, and a few other BSD. Now all of those were worse. Even worse. I couldn't believe it. So Windows, and this is something that Windows does get right. Windows uses interval trees. They get that right. But this will be fixed in Linux, but it's also being fixed in Samba because Samba also runs on other operating systems. But if you do a lot of locking, then you need to be a systems programmer to understand why this happens. And then the technique is to write little test programs. And then what you do is you mail these test programs to the kernel mailing list, or you give them to somebody that you know or whatever, and things get fixed. Really good. Okay, so you need to learn programming languages. You do need to know the C programming language in detail to be a systems programmer, even if you aren't programming in C. You need to also learn at least one scripting language, such as either Perl or Python or PHP or perhaps Bourne shell scripting, just so you can be more productive in producing test data or analysing results or whatever, because doing that sort of thing always in C is too slow. You also need to know what makes good or bad style in these languages. You need to start getting some taste, some good taste. You need to know the difference between good cooking and bad cooking. That's hard to learn. That's something that it takes a while to learn. You also need to learn how to avoid common programming errors such as buffer overruns. Valgrind helps with this, and there are other techniques that help, but you need to read up about what those common techniques are. Maybe read the bug track mailing list for a while, or the archives of it, and understand the common mistakes that are made so that you can avoid them. Okay, how do you join a project? Joining a new project can be difficult. First of all, pick a project that you like, that you are interested in. Don't pick one just because you think it's sexy or you like the t-shirt. That's not a good reason. You might be working on this project for many years, and I can assure you that the glamour of the t-shirt will eventually wear off. So pick one that you really like. Read and experiment with the latest development code. Don't download the last released version, grab the development code, the code that the developers are actually working on, the bleeding edge, and read that and experiment with it. Make changes, break it, fix it again, S-trace it. You'll almost certainly find a bug. And then that's great. You're first into the project, you find a bug using S-trace. Because most people don't S-trace their code, despite the fact that they should. Anyway. You should read the mailing list and join the IRC channel if there is one, discussion channel. Participate in those forums. And once you start making contributions on the mailing list, or via patches or bug reports, make very sure they're accurate. You need to be very careful, particularly in the early days when you're new to the project. Double check all of your facts. Instead of just guessing why something is happening, write a test program that confirms that. Use S-trace or GDB or Valgrind, confirm that you are right. And be very careful, very slow and methodical, particularly in the early days.
You may have to ask on the mailing list where the IRC channel is for some projects.
That's right. Some IRC channels, some projects have a fairly hidden IRC channel. I often find Google is useful searching for project name space IRC. Sometimes finds you the channel. Sometimes they even have logs. Samba has logs of the IRC channel, so you can read all of the flame wars of the past. Yeah, the gossip, etc. And you get to know who's always flaming and who's friendly. That's good to know. You should expect harsh comments and initial rejection. That's common. It's not you. It's not that they're picking on you in particular. You will get harsh comments and rejection on most projects when you first start joining it. It's the nature, it's one of the reasons why open source code ends up being good quality, because people don't put up with bad code. They are harsh, they do criticize it, and it ends up being stronger and better for it. But that can be difficult for beginners. Several times I have posted messages to a new project that I'm helping out with, like recently Open LDAP and things, and you get back very harsh messages. You're not necessarily